Okay, now that we know what a chemical reaction is, and we know the kinds of chemical reactions that can take place, we're going to start looking at writing and balancing chemical equations. Chemical equations are just a shorthand way for us to write out what's happening in a chemical reaction. So instead of having to write it all out in words, we're going to write it in symbols. But we could just as accurately write it in words. Before we start looking at the actual equations and how to write that, though, let's review the law of conservation. The law of conservation tells us that matter cannot be created or destroyed. That means that whatever matter we start with, we have to end up with that same matter at the end of whatever we do. This is important to chemical bonding and chemical reactions because that means that whatever atoms we start with, whatever particles we start with, we can rearrange them and let them bond differently, but we cannot lose any atoms and we cannot gain any atoms. Right? So we already know that when we write equations, we start with reactants on the left and products on the right. In the middle, we put this arrow, and that arrow stands for yields or produces. So this tells us that some reactants react with each other, the bonds break and rearrange to produce some products. Right? Let's look at an example. You might have something like nitrogen reacting with hydrogen to form ammonia. Okay, so nitrogen and hydrogen are my reactants and ammonia is my product. Sometimes the equations can give us even more information than just what compounds or molecules are involved. Sometimes they'll tell us even what state of matter they're in. They might put a little S for solid, or a little L if it's a liquid, or a little G if it's a gas. All of these are gases at room temperature. If you see this, AQ, that means aqueous. That means it's dissolved in water. It's a solution. Okay. These numbers out in front of the symbol of the formulas, these are called coefficients, and they tell us how many of each molecule we have. So we have one nitrogen molecule reacting with 3 hydrogen molecules to form 2 ammonia molecules. Okay, so that's what that means. When you're looking at formulas that have a coefficient, remember that you need, just like in math, you need to multiply by the coefficient. So if we have 3 water molecules, that means that we don't have just 2 hydrogen atoms anymore. Now we have 2 times 3 is 6. We don't have just 1 oxygen atom. We have 1 times 3 is 3. Okay. Here, if we have, say, 4 magnesium nitrates, we don't have just 1 magnesium, right? Because we have 4 magnesium nitrates, that means we have 1 magnesium in each of the 4 magnesium nitrates to give us 4 total magnesiums. Nitrogen, we have 1 nitrogen times 2 is 2 in each magnesium nitrate. So 2, and we have 4 magnesium nitrates. 2 times 4 is 8. The oxygens, same thing, right? We have 3 times 2 is 6 oxygens times 4 is 24 total oxygens. So when you are balancing equations, you're going to need to use coefficients, and you're going to need to remember to multiply everything in that formula unit by the coefficient. All right, so let's actually look at how we balance a reaction. The first thing we need to do is we need to count what's on each side of the reaction. We need to count what's on our reactant side and what's on our product side. On our reactant side here, we have just 2 hydrogens we have 2 oxygens. On our product side, we also have 2 hydrogens and 1 oxygen. My hydrogens are balanced, right? I started with 2 and I ended with 2. My oxygens, though, are not balanced. I started with 2 and I ended with only 1. That's a problem because the law of conservation tells me that I can't destroy that oxygen atom. So what that tells me is that I don't have just one molecule bonding with one molecule to make one molecule. I have more than one of some of these, and I need to figure out how many of each I need. Since obviously I need another oxygen over here, I couldn't have gotten rid of the oxygen from the reactant side, so I need another oxygen on my product side. I'm going to assume that means I need a whole nother water molecule, right? Giving me a total now of 2 and 2 is 4 oxygens, and 1 is 4 hydrogens and 2 oxygens. Now my oxygens balance, but my hydrogens don't. So that means that I need an extra hydrogen molecule. Now I have 2 and 2 hydrogens on my reactant side, giving me 4 total hydrogens and 4 total hydrogens on my product side. 2 total oxygens on my reactant side, 2 total oxygens on my product side. So now this equation is balanced and I can write out the formula. I actually needed 2 hydrogens, so I'm going to put that coefficient of 2 out in front. I only needed 1 oxygen molecule, so it doesn't need a coefficient. And I needed 2 waters, so I'm going to put that coefficient. Okay. Let's look at the rules that we have to follow. Whenever we're balancing equations, we have to follow these rules. We cannot change the subscript. Notice that I didn't just change this to H2O2 to make it balance. That is a big no-no. H2O2 is not the same as H2O. So I can't change this. I have to leave each formula unit the way it is written. I cannot change it at all. Right? I also cannot put coefficients in the middle of a molecule. I can put coefficients in front of molecules, but I cannot put them in the middle. That's why you didn't see me doing this with a big old 2 in front of the oxygen. Right? I can't change the coefficients and I can't change the subscripts, and the coefficients can only go in front. So those are 2 things I cannot do. The one thing I must do is make sure that my numbers are whole numbers, my coefficients are whole numbers, no decimals, no fractions. And if for some reason I need to reduce. For example, when we were balancing water, if I had said 4 H2s plus 2 O2s gives me 4 waters, you should notice that 4, 2, and 4, these coefficients all have a common factor, and that common factor is 2. So I can reduce that down. I can say 4 divided by 2 is 2. 2 divided by 2 is 1. Remember, we don't have to write ones. And 4 divided by 2 is 2. So if I can reduce my coefficients, not my subscripts, if I can reduce my coefficients, I must do so. Let's do a couple more balancing practice problems so that we can get the hang of it. Okay, over here on my product side I have 2 hydrogens, and on my reactant side I have 2 hydrogens, and on my reactant side I have 2 chlorines. On my product side I have 1 hydrogen and 1 chlorine. So this is not balanced. This is not balanced at all. So what I need to do is get enough hydrogens and chlorines on my product side that they do balance with my reactants. I can do this by adding another compound unit of HCl. That's hydrochloric acid. Right? So now I have 2 hydrogens and I have 2 chlorines. Now I balance. So when I write my balanced equation, I needed only one hydrogen, I needed only one chlorine, but I needed 2 HCl. So I'm going to put a 2 out in front of HCl. Okay, let's do another one. I have P4O2. Notice this time it doesn't tell me what state of matter they're in, and that's okay. It won't always tell you. On my reactant side, I have 4 phosphorus, 2 oxygen. But on my product side, I have 2 phosphorus and 3 oxygen atoms. So again, I'm out of balance. I've gotten rid of some of my phosphorus, but I've added an extra oxygen, and neither of those things are allowed according to the law of conservation. So, since I need more phosphorus over here on my product side, I'm going to add it by adding a whole nother molecule of diphosphorus trioxide. Now, I have 2 and 2 is 4 total phosphorus, 3 and 3 is 6 total oxygens. My phosphorus balance now, so that's good, but my oxygens don't. So I need to work on that. So I'm going to add another O2. Now I have 4 oxygens, but that's not enough. So I need to add another O2. 1, 2, 3 O2s. 2 and 2 and 2 is 6, so I have 6 oxygens now, and that balances. So now I can write my balanced equation. I needed 1, 2, 3 O2s, and I needed 1, 2 P2O3s. Notice that I'm keeping it O2. I'm not saying O6 here. I'm saying I have 3 O2s because that is what I had. I had a little molecule of O2 and I had 3 of them sitting here to react. Let's do one more practice one, because I don't want you to get nervous when you see something big like this and long. It's no different. You do magnesium, fluorine, lithium, carbon, oxygen. On the other side, the same thing. I'm going to do it in the same order because that makes it easier. On my reactant side, I have 1 magnesium. I have 2 fluorines, 2 lithiums, 1 carbon, 3 oxygens. On my product side, 1 magnesium, 1 fluorine, 1 lithium, 1 carbon, 3 oxygens. The only things out of balance are the fluorines and the lithiums. So I'm going to just say I need another lithium fluoride here. That gives me 2 fluorines, 2 lithiums. Everything else stays the same. So I can write my balanced equation now because now everything balances. So magnesium fluoride plus lithium carbonate react to give me magnesium carbonate and 2, you see that? 1, 2 lithium fluorides. And there we have it. So here's what you should have in your notes. You should know these things, and you should have these things in your notes, including example problems for balancing equations. If you do not have these things, please go back, listen again, and write these things down.